Welcome to MyProject Bazaar.com. Now we can going to discuss about the product, a reliable three-phase transformerless grid connected PV inverter with the inductive DC link. Now we can going to discuss about the abstract of our product. A modified buck boost grid connected three-phase photovoltaic inverter is presented. In the structure of the inverter, an inductive DC link is used between input and output. The merits of the employed inverter are soft switching and step up and step down conversion without any additional power converter stages. It is a transformerless inverter with no leakage current issue. Moreover, as the result is increased the switching frequency, it offers output current total harmonic distortions within standard limits. It uses only one current sensor. There is no electrolytic capacitor in it, which leads to high reliability. The operating principle is toughly explained and a simple strategy with a new maximum power point tracking algorithm is proposed. The simulation results are provided to verify the behavior of modified inverter. It is control strategy and maximum power point tracking method. Next we can see about the flow diagram of our product. First we can see about the sunlight. Sunlight is our irradiance level to given the solar panel of our system, because for example you take the 1000 irradiance level to get input of a solar panel is processed to the solar panel, some power generated to process the maximum power point tracking. There is a new maximum power point tracking of proposed system. The technique of our algorithm process. This process sent to the DC to DC boost converter. This boost converter is sent to some boost up energy levels to maximum power point tracking to improve our energy levels of our power in this DC to DC converter. Intermediate section of duty cycle with the switching pulses are to define the duty cycle with the switch on the pulses of DC to DC boost converter. This is switching of our DC to DC boost converters. Next we can process to the DC to AC converter. This is an our conversion totally change. This is our power is given to the DC. It will change to the AC converter. It will energy is stored to the AC grid. So we can see about the intermediate section. It is an to DC to AC converter. It is using the pulses of sinusoidal pulse width modulation to switching pulses of DC to AC converter of triggering the pulses of IGBT of our switching characteristics of pulses. The entire system has stored in our AC grid to of our conventional source. Next we can see about the running process of our product. In this proposed system implementation done in MATLAB version 2013A, first open the MATLAB file window and create a new model file. After create the elements as per the circuit diagram of our base paper. The arranging elements of the output waveform will corresponding scopes are connected in the circuit diagram. This is our circuit diagram. Next we can see about the results. First we can see about the PV characteristics. This is an solar generates the PV characteristics result of our power voltage of our PV characteristics results. Next we can see the IV characteristics. This is current and voltage characteristics of these results also. Sun wave. This is our grid voltage. We can see the purely sinusoidal wave of 3 phase to connect the grid connection wave as per that. Next we can see about the injection current. This is grid injection current in between the line to our power generation. Some phase shift relays of different phases. We can see the R phase as some linearly normal, but Y phase condition downly leading waveform has some difference to inject our power to grid line of our current. Next we can see about the DC link of solar panel. This is an our DC link. This is an to step up the process of largely step up. This is an purely DC wave, as we can see DC wave as that. Next we can see about the maximum power point tracking algorithm to given a duty cycle of our triggering pulses to the DC to DC boost converter. This is an our master triggering pulses. This is an saturation region of our triggering pulses with the duty cycle. This ratio. These are some levels as that. Next we can see about the sinusoidal pulse width modulation. First we can see about the triangular carries wave. Next we can see about the sine wave of our pulses. Next we can see the triggering pulses of our DC to AC converter of these pulse ratios to trigger on the switches of individual of six pulse switches. Wait a second, this is an our total wave. We can see as that linear waveform. As next we can see about the switching pulses of our switches. This is an our switching pulses of our switches. We can see the different duty cycle. This is an on area. This is an opposite off area. This is an some pulse width to range to variation. This also our switching pulse of our characteristics with the respond to our duty cycle.